discussion with the neural-relational framework. Okay, great. So the way I view it, and I'm going to try to keep my comments brief here. Maybe we could lower this thing a little bit. Yeah. Okay. In many ways, this is probably an oversimplification. At a sort of archetypical level, I think of there as being kind of three modeling eras for dynamic modeling. The first of them was, in some ways, indicative of sort of the work in system dynamics in the 1960s, 1970s. Consult us, we'll bring you the answer. Come, tell us about your problem, whatever your problem is. Problem in rail yard management, stock management for rail, come tell it to us. Problem with, urban planning, come talk with us. Problem with business competition strategy, come talk with us. Problem in health, oh yeah, come talk with us. We're your people. We'll solve it for you. Generalist modelers, independent end users. They get advice for this. They wouldn't be able to understand the model, be told sort of what to do. And there was quite a technocratic sort of elitist sort of attitude that built up around that you'll see even manifested to this day in some quarters. Second era, models have been built and distributed as black boxes. This is how ModGen is used in Canada for the life paths model, for example. These large-scale micro-simulation models, they're built, they're distributed, people can run them in teams, but you can only run within the confines of this little interface that they've pre-designed. And you're not sure what's quite in the black box. So assumptions about the scenarios and outputs, those are all predefined ahead of time. You have limited understanding of the assumptions, and the model evolves, but it evolves out there. You sort of say, oh, we need to get StatsCan to incorporate a version that takes into account physical activity or something like that. And they go off for 2 years and 3 years, and they work on it. This technique this era that I think I see us as entering into, in part because of advances like AnyLogic's, and I think AnyLogic is most notable here, but it's not the only one, allows for agile modeling, what I call agile modeling. It's collaborative, it's adaptive, it's embedded. So interdisciplinary, model building alongside end users, sitting alongside them. There may be a person who's taking the lead on the modeling, but they are literally sitting next to and having people look over their shoulders and give input and give comments, and give feedback, who kind of are savvy to what's going on in that model. The model is relatively transparent to non-modelers. Yeah, there's some things in there that are opaque, but here and there, but the broad scope of it, think about state charts, think about a depiction of the stocks and flows. They kind of have some pretty good understanding as to kind of a lot of the elements of it. The end user, I see, is increasingly being able to customize the outputs here. This is hard right now, but we're working on tools with AnyLogic and with Repass to make this really easy to do. So you could I could give you a model and you could pick, I want to see this additional thing. I want to look at this also. I want to break this output down in this way without me building that in ahead of time. This is beyond the state of the art with AnyLogic, but we're very close to it, and I think within another couple of years' time, it will become more and more standard. End users help evolve model assumptions as they see it, and the model here is a living document. It evolves with learning about the situation, learning from the evidence, finding inconsistencies between what the model reports and what's seen empirically, and refining the model accordingly. So I started this boot camp with this masterclass with a comment on a vision of models as thinking tools. They help us learn more quickly from the evidence by thinking through the implications of our assumptions more consistently. We have the software total up the implications of what we're characterizing to it in terms of the dynamic behavior. It does that for us. We don't do that in our head. So it does it more consistently, reliably, and rigorously than we can do more. It helps us learn more quickly as well and more thoroughly from whatever empirical evidence has evolved. So the idea is that the model is sort of a way of capturing our operationalized theory, and it helps us figure out if that theory jibes with what we know from the world more quickly. And, you know, this puts this evidence to bear for informing our choices and informing our understanding in terms of refining our models, which data to collect, which intervention to undertake. So there's this kind of vision of the modeling process as something which involves a model, here shown as system dynamics model, produces output, sort of opens ideas, oh, you know, that can't, gosh, you know, I've been thinking about it this way, but this evidence is from the model, or this output from the model is totally inconsistent with what I see from the world, so it refines my model, my mental model, which then might motivate me to collect more data from the world and potentially intervene. So I talked about these sort of levels of the modeling process. And I view the modeling process, this process of sort of getting together, discussing, reflecting on what do we know as a group, do we really know that, what's changing, how do the different pieces of the system fit together. You may be an expert, you know, in this aspect of the health service delivery context, you're in another area. Maybe you have a health service, you know, a allied health professional involved who knows about this other set of processes. And all of them, as part of the modeling process, this thing is skipping forward, as part of the modeling process, they are all coming together to sort of comment in a single way, or with respect to a single artifact. So they're kind of having a meeting of the minds, as it were, about what we collectively know. And that's a very powerful process. Even if the model itself is lost, something powerful has been gained. Sometimes it's consistent terminology. Sometimes it's a sense of how each of us fit in with this system where we always weren't quite sure what they did. Now we have clarity about how their actions end up affecting us or vice versa. That's a very useful thing organizationally and in terms of planning for systems change. And I think it's a very important part of modeling, how it stirs up this understanding. Now, in our projects, particularly in recent years, the past 5 years or so, we've put a really heavy emphasis on this agile modeling, working alongside people, building up any logic models in large part to try to do that in a team context that's highly interdisciplinary. So rather than us going back, writing the model, describing it, and taking it to someone 6 months later, we try to work, you know, once a week or maybe even every day. And this is really what we're doing with our Ministry of Health project right now, and it's a strategy we've taken in other projects as well, some of them listed here. So here, importantly, the folks who are not the primary modelers still will be running something like any logic. They'll still be able to use the model and interact with it. At the least, they can look at it and know basically what it means. So in this area, the models function as a boundary object. And that's probably foreign terminology for you, just as it was to me. But the idea is that we can have these people from all different backgrounds: computer science, epidemiologists, folks from public health, clinicians, folks from the social sciences, social workers, all sitting in the same place. And they can communicate more effectively because they can point at the model. They can be talking about a common thing about the process and know what they're talking about, in part because the model is there to sort of serve as a point of reference. So they can point to something in the model, and each of them might describe it in their own jargon, but they have some common understanding of what they're talking about. And that lowers some of the communication barriers, and it helps open up some avenues towards sort of more effective sharing of ideas. And I would argue the modeling approach and the software used has a major impact in this. So if you're using Repast and you're writing large volumes of Java code, you're going to have a hard time showing that to a clinician. Now, you might, in justification or in recognition. You might try to boil that down to a diagram, but in my observation, that's not done an awful lot. A system dynamics diagram, or a stock and or a state chart, those might be quite amenable. So when we system dynamics has long been used for this reason. For well over a decade now, system dynamics models have been used in what are called group model building processes. Working with, early on it was mostly institutional stakeholders and companies, but increasingly you see it with communities to serve as boundary objects. And there's some powerful stories I don't have time to go into about how system dynamics diagrams, causal loop diagrams, and stocks and flows can be understood by people in very quick levels. So they could take a diagram like this, and you can teach someone who's never seen this sort of diagramming before, within the span of 10 or 15 minutes, they can have a pretty good understanding of what this means and how to add to it or question it, interrogate it, or expand upon it. Same thing with a stock and flow diagram. There's something very descriptive and declarative about that. Now, recently, predominantly I have to credit AnyLogic. Repast is trying to follow suit to a degree, but it's not nearly as far along. Is this move towards allowing ABMs to have fairly declarative way of characterizing the structure of the ABM. So a focus on what is being modeled and less on the how. And these specifications do support, growing use. And much of the goal here is to get the programmer out of the learning loop. Just as I do not wish to be caged, I do not wish to be in the midst of the learning loop, trapped in the learning loop. I don't want to be the person you have to go to. Could you add this output? Could you interpret this? Could you tell me what the model says about this? That should be something you can do yourself. You should be able to ask what-if questions and see the results. And ladies and gentlemen, I know many of you have found this masterclass very challenging, technically. I know it's really stretched your boundaries. And I know many of you probably don't have any realistic sense that you want to build a model like this from ground up. But I would argue that everyone in this classroom, every single person in this classroom, could probably very fruitfully take models in AnyLogic and run them, right? Could run them. You could probably use them to explore graphically, go down to the individual level, see what's going on. You might be able to create a new scenario, change the parameters for that, and observe the results by running it. These are things that are much, much more readily accessible than building the model from scratch. And you'd be surprised, there's kind of this punctuated nature of modeling. The actual time hands-on building up the model, as we've been doing this week, in terms of the model ecosystem, that might only be 10% of the time, 5% of the time. Most of the time is actually spent running the model, seeing what the results are for different scenarios. Yes, you add something on maybe to it, maybe you add a scenario and a bit of logic for it, but comparatively speaking, in terms of use of the model, tends to dominate building up the model. And this is one of the reasons that I do think it's quite accessible to have people from any background highly involved in shaping a model in this area. Even if you just have a buddy who helps you build the model, then once it's built, you might be able to use it, for weeks on end without actually a serious modification. So, right now, and I recognize it's painful, if you want to examine new questions regarding a model's behavior, you've got to do some things which might stretch you a bit. Adding statistics to the population, remember that? Creating new tables or charts, creating a new chart. I know it's not super easy. Think about, adding a histogram. You got to add that event to update the histogram. You got to have that reset. You got to have that histogram data I know it's not in all of your comfort zone. I know it's not in all of your happy places, right? But it is something where I think it's becoming much easier over time. We're working to try to get this totally out of the loop with AnyLogic 7 within the next year or two, to have a tool that will allow you to do most of this without modifying any code. You'll be able to break things down in different ways for many, not for all, but for many, many outputs. And I also think there's a lot of benefit to be gained from improved agent-based modeling languages. I think AnyLogic, this is an example of more fulsome AnyLogic model. This one was built under my supervision, and you can see it's quite hierarchical. You've got these hierarchical states and so on, but it's quite graphical. You can show this model. This is actually from simulating the behavior of mule deer with a prion-based disease, chronic wasting disease. But you can show this to a vet, and they can parse a lot of what's going on, particularly if you give them 15 minutes to talk about the meaning of different types of transitions, etc. So they can understand, okay, there's summer movement captured, a movement during rut, and there's this kind of overriding need to go get water. So there's these seasonal groupings, and then there's these different stages of infection. They can parse it. They can parse it even if they've never used AnyLogic before. And similarly, some of our models for Ministry of Health, very accessible to others in the team. State charts to describe evolution in assistance for the Saskatchewan kidney program there. We saw this coupled state charts. Discrete event modeling, which we didn't have time to talk about this week, but it's the third type of modeling, very powerful for representing resource-constrained flows, governing people's flow through defined sets of processes, where that flow through there is governed by the availability of resources. This is also a very visual depiction, and this is another model from our interactions in our with our Ministry of Health context. This stakeholder participation that we're talking about here is not merely something that's convenient. It's something which can be fundamental in terms of building confidence in the model by a wide variety of parties, building a sense of ownership in the model, securing input to the model from a wide variety of people, hearing many voices there, facilitating data collection or identifying data sources that are relevant, because sometimes people in a group may not be aware of what the model could use unless they start interacting with it and seeing the level of detail it offers, the level at which it describes things. They might come up with ideas for novel data sources, etc. And it's very good for getting critiques of model behavior. You take someone who's an expert in a certain area of the system and you show them a simulation model showing the behavior of that part of the system as well as others, they might be able to provide some very good feedback. Remember, ladies and gentlemen, my argument that when a model doesn't align with data that we know from the world, it's not a failure, it's an opportunity to learn. Fail early, fail often. You may have heard that sort of chestnut. And the idea is, it's better, how did Jeff say it? It's better to be wrong than to be confused. And that sounds like a very, very scary philosophical statement, but what that means is it's better to try advancing something, try doing something, even if it's wrong, and get feedback on it, get critique, realize, learn that you're off base, than it is to just kind of wallow in confusion and not be sure what's going on. At least by venturing, someone said once, nothing ventured, nothing gained. You try something, you try some representation, and you get feedback on it. Maybe it's feedback that someone else says, oh, come on, I've never seen anything like that. There's no way we see patient volumes like that, or there's no way we see case counts like that. And at least then you've advanced the understanding. You say, oh, okay, so what sort of case counts do you see? Help me understand more. So when someone says that's off, great, speak on. So what is the appropriate sort of number then? It's a way of bringing in knowledge from other people that otherwise is trapped in their heads. Unless they encounter your model, they may not know that it could use their knowledge in this area. If they look at it and they critique it and say, that is clearly off base, you've got something that's off, you say, great, tell me what it should be. It's a bit like Tom Sawyer painting the fence, right? You're not really snookering, but you're getting someone else into the game to help you out without them realizing that they're really doing you a favor. Jeff once said in another famous utterance, it's amazing what you can do if you don't care who gets credit for it. And I think a fair bit of Jeff's life and a fair bit of my life have been spent giving truth to that aphorism. But the fundamental thing is that if you can get people to critique, if you're open to critique, it's a great opportunity to learn because they're contributing something you didn't know. It's not something to be pushed away, but something to be used. And again, they may say, well, you didn't know about this data sort? Yeah, we collected that 3 years ago. It's just never been published. Great, let's go get it. So Peter Hoffman has done a lot of work in community group model building to elicit community mental models, community community understanding. And much of this is about using the community to identify barriers for them and challenges that they're overcoming, but also much of it focuses on eliciting perceptions. Because sometimes some of the most operative things are not merely what is, but what is perceived to be. And if you'll talk with Jeff, he'll talk about perceptual control theory and the fundamental ways in which perceptions play in shaping our behavior and way of parsing the world. And I have great respect for Peter's work, Peter Hoffman's work. The way he described this is an interesting sort of story. But this woman here, they were meeting with this village in rural India about, I believe, water shortages there. And they started drawing, I think in the local language. They met with a community group who was all male, incidentally, entirely male. And this group started working, and they kind of learned the language of cosmic diagrams. This was all in the span of an afternoon. And they kind of drew out, okay, we have these, we had plants normally, but the plants got stripped away because we needed firewood, and therefore it left the hillsides more prone to erosion. Therefore, the water rushes down them instead of sinking in the soil. And there was this set of dialogue going on between the team and the folks there, and they were talking about this stuff. And they drew these things out on the board. And then this woman came in to grab one of the men for something. She came in and she was there and she was observing what was going on. And then she walked up to the board and said, no, you've forgotten these links. You neglected the fact that we got these foreign cows that are more water hungry than these. And these actually link in with this issue and this issue. You need links here, and you've neglected to break out, additional variable. Within watching this for, 5 minutes or 10 minutes, she recognized some limitations, and she was able to contribute. Yes, it's just one anecdote, but the point is that using qualitative models to elicit sort of understanding on the part of community members to hear voices that otherwise wouldn't be here, it's a very powerful technique. And Peter's work has done this in inner city schools, with bullying, and with a variety of cultural settings in Mongolia, I think multiple settings in India, etc. Personally, it's very different than what we've seen this week, but I think it's quite complementary in terms of eliciting some of the understanding of the causal connections in that particular context. It's a different side of modeling and one I wanted you to know about. Very powerful. And I've been privileged to be in collaboration with Ross Hammond, Peter, and others, and Kurt Stange, in adapting this sort of technique for agent-based modeling. Because one of the recurrent problems that I've seen, I don't know how Jeff feels about it, but one of the recurrent problems I've felt at times with system dynamic models is the fact that sometimes in a given causal loop diagram, you have things going on at two totally different scales of aggregation, at an individual level and then suddenly at this higher level. And an agent-based formulation of this, or reformulation or rejigging, can be quite helpful for sort of clarifying or getting away from some of those stumbling blocks which might otherwise confuse people. So anyway, very powerful technique and very useful. I hope these comments on some things about the human seater of modeling have been useful. I know I'm talking in generalities and so on here, but I'm trying to share with you some heartfelt observations over years and years in modeling about the way things are changing in that domain. And I think it's really exciting. I think this idea of doing embedded modeling, agile modeling with teams, and increasingly with communities could really be quite transformative in creating, as Jeff puts it, useful models that get used. Models that are not merely useful, but are actually put into place. Jeff, do you wish to say anything on this score?
No. I thought help Dylan get some thoughts.
Okay, fair enough.